Hello, everybody. I'm Barry David Josephs. I'm a chemical engineer, patent attorney. Nature has provided us with equilibrium in many different forms. For example, there's gravitational equilibrium. In biology, there's cellular equilibrium, and at the atomic scale, there's atomic equilibrium. I'm the author of the book, Chemical Reaction Equilibrium Theory, Pathways to a Better Understanding, 3rd edition. I also have published a predecessor book entitled Gaseous Chemical Reaction Equilibrium. Both books are currently cataloged in between about 15 and 20 university libraries. Most are listed in worldcat.org. They are Tufts University, Northeastern University, Princeton University, Worcester Polytech, McGill University, University of Pennsylvania, Salem State University, University of Michigan, Suffolk University, University of Wisconsin, University of Delaware, University of Texas, University of California at Berkeley, California Institute of Technology, University of Windsor, Ontario, Nova Southeastern University, and the University of Colorado. I have embarked upon writing the books for the purpose of presenting chemical reaction equilibrium theory in a step-by-step manner developed from classical first and second law thermodynamics. The prime objective is to help students and those interested in this topic to better understand the theory and its ramifications. I present the theory from several different perspectives to facilitate understanding. I have written these books over a number of years, periodically adding content to make the work more comprehensive. Here's a shot of the cover page of my book. The underpinnings of the theory involve application of the Gibbs energy function for reaction systems held at constant temperature and pressure, and the Helmholtz energy function for reaction systems held at constant temperature and volume. For a reaction proceeding towards equilibrium, the total Gibbs energy of the system falls as the reaction proceeds and finally reaches a minimum value at the point of equilibrium. At this point, the rate of change of the Gibbs energy becomes zero. One important result of the theory, which is presented, is the formulation of the equilibrium constant for gaseous and liquid, ideal or non-ideal mixtures at reaction equilibrium. The equilibrium constant allows for calculation of the composition of the final equilibrium mixture. Methods of calculation of the equilibrium constant as a function of temperature are presented as well. there is a short method and a long method of calculation of the equilibrium constant as a function of temperature. I have presented both methods in my book. Related theories are also presented. One such related theory is that of calculation for maximum mechanical energy attainable for a chemical reaction as it proceeds to equilibrium. Another related theory is presented from the application of Gibbs energy. It is the derivation of the Nernst equation. The Nernst equation predicts open cell voltage of an electrochemical cell for different combinations of anode and cathode chemistry. In actuality, the real cells are not 100% efficient, and so the real voltages deviate a little bit from the Nernst equation. Another derivation presented in my book is that of the Gibbs-Duhem equation. In closing, I wish to point out that the foundation for chemical reaction equilibrium theory comes from many scientists. They have contributed to the development of classical chemical thermodynamics over a long period. I would say over at least the last century and a half. To note but a fraction of significant contributors, I call out Sadi Carnot, Rudolf Clausius, J. Willard Gibbs, Pierre Duhem, Hermann von Helmholtz, Jacobus van 't Hoff, Walther H. Nernst, Otto Redlich, Joseph Kwong, Kenneth Denbigh, Kenneth Pitzer, Gilbert N. Lewis, Merle Randall, Joe M. Smith and Hendrik C. Van Ness, and Martin V. Sussman. Thank you all for your attention. I am truly grateful for the opportunity to make this video. I hope you can locate my book in your university library or else order it in an interlibrary loan. And that was the main reason I listed the universities carrying my book at this time. On a personal note, I started to research the topic of reaction equilibrium, initially just as a matter of interest. But as I delved into it in detail, I became impressed with the applied thermodynamic principles and neatness of the mathematics. I actually was surprised that the mathematics fell into place so well. So I continue to update my books with additional material and with some streamlining of the presentation along the way. Also, I proceeded because of my love for science. I hope you will have a chance to review my book, benefit from the presentation, and come away with a greater understanding of reaction equilibrium theory. Thank you all for your attention. I am Barry David Josephs.